going to be talking about tornadoes and tornado trends, and we're going to get right into it. So first thing we want to show is what the average numbers of tornadoes are in every state and in the United States. And these two maps are similar. The numbers may be just a little bit different because we're working with a slightly different time frame here. But you can see for Illinois, those numbers are the same. So on average in Illinois, we have about 54 tornadoes within the state each year. That may be a little bit surprising. It may be a number much higher than what you think it is, because in your local area, you may not have a whole lot of tornadoes, but statewide, and whether those tornadoes just barely touch down or whatever, they're still counted. As you might expect, a big state like Texas, which is also in that Great Plains, Dixie, not Dixie Alley, but Tornado Alley, the main Tornado Alley, has a large number of tornadoes. They're a large state, and they're also in an area that receives a lot of tornadoes. And you can see throughout that traditional Tornado Alley that Oklahoma has about 65, Kansas almost 100, and Nebraska about the same number as we have. We might think of tornadoes being just related to the Midwest and to the Great Plains. Tornadoes have been found just about on every continent except Antarctica. We just have the geography that makes it more conducive for more tornadoes to occur within that region as compared to other continents around the world. Now, these are some statistics that I just recently pulled up just a couple of weeks ago for tornadoes in Illinois, nationwide for last year and then beginning of this year. So if you look through 2022, we see that the largest number of tornadoes actually occurred in May of last year, which is pretty typical, but March was not far behind. May had 238 tornadoes nationwide. March had 236. And just last month, we had 168. You may remember a few of those storm events that came through, especially in the southern part of the United States, had several tornado outbreaks associated with them. I also want to include a little bit of trivia in this presentation. So the very first tornado that was detected by weather radar, by any type of weather type radar, was actually done at the University of Illinois campus, was done with the help of the State Water Survey. But as maybe some of you know, one of the things that's looked for in a radar signature is development of a hook within that storm. And you can see a very well developed hook within that thunderstorm on that picture that we can see. So that was way back in 1953 when that was first detected. When we look at directions for tornadoes, where are they tracked? Now you can see a lot of them track from southwest to northeast, but not all of them do. We have some that go from northwest to southeast. And then we have some that actually travel towards the west. But there's a few in there. If you look closely at the arrows, I see a couple that are traveling from southeast to northwest, traveling basically in the opposite direction. So while a lot of them travel towards the northwest, not all tornadoes do. Talk a little bit about types of tornadoes. First ones we'll talk about are the tornadoes that form in thunderstorms that are not considered supercell thunderstorms. Supercells are thunderstorms where the entire storm is rotating. But we can have tornadoes in other types of thunderstorms. Typically for those, the rotation begins near the ground and typically has a pretty narrow funnel associated with it. Some examples of those are gustnadoes, landspouts, and waterspouts. Again, you can see with these, not very wide, and typically these also don't last very long. Wind speeds with these are also not going to be tremendously high. They're probably not more than maybe 70 to 80 miles an hour at the most in a lot of cases. Another type of tornado that forms with a squall line. A squall line is just a line of thunderstorms that are traveling side by side, but in some cases that line will start to bow out in the middle. As the ends of that squall line start bending around, you start getting rotation on either end. And in those areas, in some cases, tornadoes may form. Again, they're typically not going to be very powerful tornadoes, but you can get that type of tornado formation with those squall lines when that bow echo occurs. Supercell tornadoes, though, are kind of a different creature. Like I just mentioned, in these cases, supercell thunderstorms, which in a lot of cases are 5 to 15 miles wide, that entire thunderstorm is already slowly rotating. Within that thunderstorm, you may have an area of increased rotation. And in this case, if you look at this picture down on the right-hand side of that thunderstorm, you see a tornado on the ground there. Not every supercell will have a tornado, but the chances of them occurring in these types of thunderstorms are greater, and the chances of these being more powerful tornadoes are greater. And when we do get these really large tornadoes, sometimes you'll hear media reports talking about a tornado that's maybe a mile or a mile and a half wide. Well, that mile and a half is really the debris cloud of that tornado that's going, but within that debris cloud, what you would find in a lot of cases, if that debris wasn't present, is that there's actually multiple funnels, and they're all spinning around a central location. So that entire debris cloud is not an entire tornado per se, but you have multiple funnels within there, all spinning around a central point. And as we've gotten more videos and more pictures around, we can see more evidence of that. But this is just an illustration of what we're talking about here. So again, you've got those multiple vortices, multiple, in this case, they're calling a suction vortex, but it's all swirling around a central point. So here's an example of two tornadoes. Again, if we had animation with this, you'd see those two tornadoes swirling around each other. Here's another example of a relatively large tornado and then a smaller tornado. Again, these would both be swirling around each other. And I'm wondering about that car that's in the front here in this picture, what they're thinking. I guess they do have the brake lights on, but anyway, I don't think I'd want to be that close to these tornadoes as they're moving. One of the other things that comes into play with these types of tornadoes, these really large tornadoes that have these multiple funnels in there, is that a lot of times you'll hear stories about within a neighborhood, maybe one house gets entirely destroyed while a house next to it or right across the street is untouched. Well, having the idea of these multiple vortices kind of explains what's happening in some of these cases. So if you have an area where a house is in between these funnels, doesn't hit directly by it, maybe the wind speed is 80, 90, 100 miles an hour. Yeah, you're going to have some damage with that, but that's not going to be anything compared to a direct hit from one of these funnels that may be spinning at 150 to 170 miles an hour, where you can have a lot more destruction. So that kind of helps explain in some cases why these types of events occur. Just looking at research, lots of research is being done with tornadoes. Some of you may have watched, well, actually, this is getting to be an old reference now, the movie Twister, where they had the multiple cars going out. And there's still research that's done that way. But in this case, a lot of times they're also taking a mobile radar along with them to do that. But in today's world with drones are used extensively as well. That way you can get close to those thunderstorms, get information from them, without having to do like they did in Twister, where they were trying to get something right inside that tornado. Just showing a little bit of the research that's ongoing, some of the more recent research. And again, one of the big questions is, what causes the air to spin faster at those low levels that reach down to the ground? And this theory from the University of North Dakota is that a sudden drop in pressure is drawing in and concentrating that rotation within the storm. So one of the things that they've done is, and this is being done by other research units also, is they'll go out, they'll take videos of an actual tornado in place. They'll also be getting, at the same time, information through the use of maybe mobile Doppler radar that they're using within that vicinity of the storm. They'll take that information that they get from the radar, they'll take the video, and they'll also, from that, be able to develop a computer program that simulates what was going on within that thunderstorm and see if it does create a tornado. And in some cases, they have enough information, they put that into the computer, and a tornado is generated within the computer from the information that they got from their observations. Also, to talk a little bit about University of Illinois research. They've developed a new technique for looking out for an extended range, not to say exactly when a tornado is going to occur, but the likelihood of a tornado outbreak that may occur. From this, they're looking at persisting weather patterns. So something that's lasting typically more than 3 days. And they've seen from the research that in some cases, these extended weather patterns contribute to greater than 70% of tornado outbreaks. So based on that, they developed a hybrid software model to predict tornado activity out to even multiple weeks. And this model that they've developed does demonstrate some skill even out to week 3. So that's some encouraging news that's coming out of the University of Illinois. One of the other things that I wanted to touch briefly on, some of you may be in an area where you have outdoor warnings or those outdoor sirens. One of the questions that we get, or one of the concerns we have, we actually, there was someone in in the extension unit that I'm located in, that's a volunteer fire person. They said that one of the things that they hear a lot from folks is that outdoor sirens cannot be heard indoors. Well, the main thing is an outdoor siren is only meant to be heard outdoors. It's not meant to be heard in an indoor setting. So in a lot of cases, those sirens are going to sound off if there are tornadoes close by, if there's very severe weather close by, such as large hail or very windy conditions. So what that siren is telling people is they need to go inside. Don't look around, get inside, and then once you're inside, turn on your radio, turn on your weather app, turn on your TV. Again, those outdoor sirens are not to be told to be, are not meant to be indoor warning systems. All right, so we were supposed to be talking a little bit about tornado trends, and that's exactly what we're going to do. So looking at how the number of tornadoes have changed in Illinois since 1950. And this comes from the state climatologist office. You can very easily see that there's an upward trend there in the number of tornadoes. In the 50s, we're talking anywhere from, well, less than 30. By the time we're in the 1970s, we're seeing up over 100. And by the turn of the century, we're seeing a lot of yearly tornadoes, if not well over 100, they're well over 60 in a lot of cases. So those overall numbers have been increasing. When we look at all the tornadoes together, again, we do see that increase, whether we're talking about anything from the weak to the really strong tornadoes. And you can see that upward trend very easily in this graph. But where we see a lot of the increase is in the weaker tornadoes, those EF0 or EF1 tornadoes. That's on the lesser end, the slower end, I guess you could say, in terms of velocity for tornadoes. When we look at the other extreme, though, those really severe tornadoes, especially the EF5s, those are not increasing quite at the same rate. That, yes, the numbers are increasing, but not as much as those really weak tornadoes. Now, the other question that you may have is, well, we're just seeing more of them because we've got better instruments to do that. And that is absolutely right. We have radar now. We have more storm spotters. We have video. But statisticians have been able to take that part out of the overall trend. So even with that observation bias, where we know we're seeing more simply because we've got more instruments and more eyes out there, we're still seeing an overall trend of increasing tornadoes. And when do we see the most tornadoes? What time of day? Probably not a surprise to a lot of you. It's in the late afternoon. That's typically when we have our greatest thunderstorm activity. And 5 o'clock, by far, is when you see the greatest chance for tornadoes. And really, anything from about noon to 8 p.m. is the biggest window for tornado activity. That doesn't mean that it can't happen in the middle of the night. We see tornadoes even in the middle of the night. Just that the likelihood of them aren't as great as the late afternoon. Like I've already mentioned, the greatest number of tornadoes that we have are on the weak end of the scale, that EF0 category. The more stronger the tornado, the less chance of it happening. And by the time we get into the EF4, EF5 category, especially the EF5 category, very rare for those to occur in Illinois. We still can get them, but the chances of them are not nearly as great as what those EF0, EF1, and potentially EF2 category tornadoes are. One of the big trends that I did want to talk about, though, and this is looking at a larger scale area, is here in the Midwest and really stretching down to the Gulf of Mexico. Now, that regular tornado alley that we've talked about for years and years and years, that goes from Texas, Oklahoma, Kansas, Nebraska, even up into the Dakotas, still experiences the largest overall numbers of tornadoes. But what the trend has been is that area is starting to have fewer tornadoes overall, still more than everybody else, but where there's an increase in numbers is what's being called Dixie Alley. And you can see that number of tornadoes are increasing from the Louisiana, Mississippi coastline up through the Midwest, including Illinois. So that whole area, and really the bullseye for that area, is in eastern Arkansas and northern Mississippi and the western, I guess, southwestern end of Tennessee. And we've seen in cases where we've had some of these large tornado outbreaks, that has been an area that has seen their fair share of tornadoes in the last 5 to 15 years. So what do you look for? Some of you that are listening today, you may have taken storm spotter training through the National Weather Service. But what do you look for the potential for tornadoes? I'll show you a few basic things. Now, before I do that, I do want to stress safety. And we are going to talk a little bit more about tornado safety here in a little bit. If you hear that a tornado warning is out for your area, don't go outside and look around to see if you can see it. If there's a tornado warning for your area, your first duty is to get you and your family to a safe place. Sometimes there have been sometimes there have been a number of cases where people go out to look and see what's there, and that tornado is right there ready to hit. So safety first. One of the things that may be an indicator of a potential tornado is when you've got a really strong inflow of moist, juicy air. That can be shown, as we've got in the picture here, something called an inflow band. So that little horizontal streak that you see there is where you've got a very fast inflow of warm, moist air. Now, there isn't a tornado that's forming out of this yet, but that's an indicator that that might be an area where a tornado may form. Something that looks very similar is something called a beaver tail. Again, it's kind of an observational thing where you're looking at what direction you see this, but you can see here this low-hanging thing. That's a cloud formation, again, where you've got strong inflow into that storm. One thing that is a very good chance that you may have a funnel come out of, and these are especially associated with supercell thunderstorms, is something called the wall cloud. So you can see this lower hanging part of the storm right in here. And if you looked at that, was able to see it, that entire wall cloud would be rotating. So you've got rotation within that, you've got rotation within the overall storm. And then if you get increased rotation within that wall cloud, that's when that funnel cloud may start to form and come down to the ground. I'm just going to tell one really quick story here. I grew up on a farm, so that's really where I got my love of meteorology and storms. Used to love watching wall lines come in. And I can remember one time when I was in high school during the summer, we had some storms come through, and I can remember being outside on kind of an open porch talking with a buddy, and we were just kind of watching the storm pass over. And we both saw almost directly overhead something just like this, a wall cloud, and it was flying by, it was rotating. Luckily, no funnel cloud was coming out of it. And of course, being teenagers, we just thought it was really cool. We didn't understand the implications of what that could have meant. Like I've said, sometimes the eye and your observational bias can maybe play tricks with you. So just because you don't see that funnel cloud there, you may have a tornado in place, but it just may not be all that visible. So in this case, this is from out in Nebraska a few years ago. But this was an actual tornado, but you just really couldn't see anything happening. On the other hand, if you look at this picture, look on the left-hand side of the picture, definitely looks like a tornado there, doesn't it? But there's no rotation within that. So that is not a tornado. It might have been a microburst or just an area of really heavy precipitation, but that was not a tornado because there's no rotation, or there was no rotation within that particular area. All right, talk a little bit about tornado safety here. So these are things from the National Weather Service, which is part of the National Oceanic and Atmospheric Administration. So let's just go through a few of these. So when you're confronted by a tornado warning, you should open all the windows to equalize the pressure. Should you? Well, like it says below, this just wastes valuable time. Don't worry about equalizing the pressure because the roof ripping off and the pickup truck smashing through the front wall will equalize the pressure for you. Here's another one. Tornadoes may occur in the middle of the night and even during the winter. Well, hopefully you already know the answer to this one, and that is true. There's been a lot of instances in Illinois, even in the last few years, where we've had tornadoes in December. We've had tornadoes in January. I can remember about 10 years ago on New Year's Eve, there were tornadoes that were occurring. My area doesn't get tornadoes because it's protected by a river. And I actually get that kind of question a lot. First of all, we live here in Illinois, and no matter where you're at, whether you're in the northern, the central, or the southern part of the state, the distance from our lowest to our higher spots in any particular area is not more than a couple hundred feet. You got to think about where these tornadoes get their energy from and where they start out at. They start out hundreds and hundreds of feet above the ground surface. That little bit of relief change on the ground doesn't make a hill of beans difference to that tornado. Even if you live along the river bluffs, we've seen multiple instances when tornadoes have crossed the Mississippi River, crossed the Illinois River. That amount of relief distance and height does not make a difference. This is also a really important one. Hiding under a freeway overpass will protect you from a tornado. This myth came about a long time ago, probably 15 years or so ago or more, when videos first started becoming popular. And there was a picture of a father, and I think it was a son, that saw a tornado. They saw other people get up underneath an overpass. And then you see the video of the wind rushing through there and the tornado moving on. The big thing about that video was that wasn't a direct hit. It was kind of a glancing blow. There was another example of a mother and child doing that same thing a few years later, where they did receive a direct hit from a tornado. In other words, it went right over that overpass. What happens is in that area, you're essentially acting, that overpass is acting like a funnel. So as that air tries to flow through there, it's going to flow even faster. And in that instance, with that direct hit, the mother was pulled away from the child. Tornadoes are more likely to hit a mobile home park. And no, that's not the case. There's just lots of mobile homes around. And if they do hit a mobile home park, yeah, there's going to be a lot of damage there, but it's not more likely than any other geographic location. If you're in a strong, sturdy brick or stone building, that'll protect you. Well, you're obviously going to have a lot more protection in those kind of buildings. But again, you have to think about where you're going to be at. Hopefully you've got some type of plan in place for if a tornado hits, where everyone will go to in that instance, whether you go down to the basement, whether you've got an interior bathroom or something like that. But remember, those tornadoes, when they're a direct hit and when they've got a lot of velocity in that air, there can be a lot of debris that can hit that structure and still cause roof or wall failure. And actually, one of the first things that may go off of a house is that garage door. Going back to the movie Twister, if you want to keep from being sucked into the tornado, if you're outside, you can tie yourself to a well pipe. No, that is not the case. And like this says, if you got a rope tied around yourself in that well pipe, probably you're going to get swung around and it's going to be a tether ball and a cheese slicer for you. Like I just mentioned, when you've got really strong winds, they can do an incredible type of thing that can't be done at other times. So you can see a picture of a vinyl record here. And for the younger folks, this was the way that we used to listen to music. But this is what can happen in some cases. It all depends on the velocity of that wind, of that air. And in fact, the force of an object being blown through the air is increased by the square of the wind velocity. So in this example, if you've got a 100-mile-an-hour tornado compared to a 300-mile-an-hour tornado, so that 300-mile-an-hour tornado is 3 times faster. In reality, it is 9 times more powerful because it goes by the square of the velocity. if you may have heard this name before. If not, there is a really good Nova PBS video out that talks about Dr. Ted Fujita. Has a very interesting life. He was brought to the United States in the early 1950s by Horace Byers at the University of Chicago into the meteorology program there. He took tons of pictures of tornado damage in different areas. From all of those pictures that he took, and he would take these not only from the ground, but he would take them from the air. He would interview people that had been through those tornadoes. He was able to find out this idea of tornado families, where there's multiple tornadoes, each with a unique path, but spawned by the same thunderstorm. He was also the one that first identified multiple funnels within a single spinning area. So if you ever have a chance to watch that Nova video, I think it's just called Mr. Tornado, I think is the name of it. Just really interesting. One of the things that he did was develop that original scale for measuring wind estimates. So he took all of these pictures that he had, and from that, he could also figure out how fast that tornado was blowing in terms of that velocity from the damage that it caused. So these are not actual measurements of the wind, but looking at what damage is caused, you can get a really good estimate of what that wind speed actually was. And this uses 3-second gusts estimated at the point of damage. Over the years, there's been some additional things added to that original Fujita scale. So today is called the enhanced Fujita scale, or the EF scale. So on the low end of that scale are the EF0 tornadoes, which again are the ones that are most prevalent, the ones that we have the most of here in Illinois too. Those range from 65 to 85 miles an hour. So yeah, they are going to cause some damage, but not major damage. We go on through the other scales. We get into the EF1, EF2 scale. By the time we get to the EF3 scale, we're getting into pretty measurable damage that can be caused. That range goes from 136 up to 165 mile an hour. Again, we're getting into rarer and rarer occurrences of these tornadoes. By the time we get into the EF5 tornadoes, this is anything over 201 miles per hour. The fastest measured wind speed, actually measured wind speed within a tornado was 318 miles per hour. Just incredible. Those types of wind speeds will just completely take a house off the foundation. There really won't be much of anything left. So that is actually what I was wanting to go through today. I wanted to leave lots of time for questions because I usually get quite a few questions with this. I do want to let you know about the next Everyday Environment webinar, which will be on March 9th at 1 p.m., which is going to be on pollinators. It's called Tricky Pollinator Questions and Answers. And Aaron, actually, I meant to put in the registration link for that. If you are on and if you're able to put that link in there, that would be fine. If we're not able to do that, I would just suggest to go into the University of Illinois Everyday Environment website, and you should see that in the events calendar and be able to register from there. Like we do in a lot of cases, we do ask that you do a survey, and you can either do it by going to that link or scanning the QR code there to take the survey. But at this point, let me go ahead and see if I can get back to the beginning of the questions. And we'll just start. Okay, first question. Do we know why there has been an increase in the number of tornadoes? Could be a number of reasons. It could just be related to weather trends, that we're getting more overall humidity into the air. Our Summertime temperatures in particular have gone up some. And so there's just more there for thunderstorms to develop. And along with that, the greater incidence of tornadoes. Good question. Here's another good one. What is a derecho? We experience in Illinois a derecho, if not every year, every couple of years at least. What this is really a very powerful, long-lasting gust front. What a gust front is when you've had those thunderstorms come through, right before they come through, you feel that whoosh of wind right before the rain hits. That's a gust front. Under certain conditions, when you've got a big squall line, that gust front can become very powerful and kind of takes on a life of its own. These derechos, once they're formed, they can last for up to 24 hours. Some of the ones that we've had go through Illinois actually started out in the Great Plains, almost made it to the East Coast before they died out. They actually lasted about 24 hours. The wind speeds for a derecho, for it technically to be a derecho, has to be over 58 miles an hour. One of the last ones that really caused a lot of damage, what was it, in 2020, I believe, went through the northern part of the state. Wind speeds for that, as it was going through the northern part of the state, were upwards of 90 miles an hour. There was one back in, well, I think it was even before 2000. We had a really strong one go through the southern tip of Illinois. I remember that at the SIU Carbondale campus, they measured wind speeds, sustained wind speeds of 90 miles an hour for about 20 minutes. Tremendous amount of damage. I can remember driving along the Mississippi River a few days after that, and they had just bulldozed trees off the side of the road because there was just so much damage there. All right. Next question. Do geodesic domes do better in tornadoes versus square or rectangular buildings? Actually, I think there has been research to show that they do a little bit better because, again, if they are structurally sound in terms of what they're made, the materials are made out of, because of that shape, they can deflect that wind a little bit better. Now, if you go out to the Great Plains, especially in Oklahoma, around Oklahoma City, which seems to be a bullseye still for tornadoes, a lot of folks out there have actually incorporated into their homes safe rooms. These are typically concrete safe rooms where if the tornado comes along, they can get into it. And I've seen pictures where there's been a direct hit from a tornado on a house, and the only thing remaining is that safe room. So those kind of things, obviously there is cost to it, but they do work in those instances if people don't go outside and try to see where the tornado was at. All right, more questions here. Oh, thank you, Erin. Erin has put the registration in there for everyone for next month's webinar. And there she has also put in a link to the evaluation survey. Thank you. So another question I see is it safer to go to a west wall in the basement or the center? Really, the thing that you want to do is you want to be as far to the inside of the house as possible. You want to be in an area that has fairly close walls together. You don't want a lot of open space above you. So whether that's in a basement, whether that's in an interior bathroom, something like that, don't worry about what direction that wall is. You want to get, again, away from those exterior walls. You want to be in a fairly sturdy area where you're not going to have a lot of stuff have the potential of falling on you. One thing you don't want to do in a basement is you don't want to be right next to water heaters or a furnace or something like that. If something falls over, those other things are not going to have the potential to fall on you. Okay, another question. Why does Florida have so many tornadoes? That's a good question. If you look at thunderstorm density, Florida has the largest number of overall thunderstorms because they'll have thunderstorms, especially in the spring, summer, and fall, almost on a daily basis. So just because they have more thunderstorms, they have a greater opportunity for tornadoes to form. Good questions. Keep them coming. Has anyone actually studied whether or not trailer parks suffer more tornado hits, or is it just assumed to be silly? That's a good question. To be honest, I don't know if they've actually done the statistical analyses on those. But kind of like I mentioned before, we have a lot of mobile home areas out there, and they're going to cover a larger area than a single home does. And typically, when it does hit a mobile home area, you're going to have a greater opportunity for damage to occur. So to be honest, I'm not sure if that actually has been studied, but in terms of the statistical probability of it hitting in a particular area just because it's a trailer park, yeah, I can't answer that definitively, but you know, a tornado is going to hit where it wants to hit, essentially, is what I can say for that. All right, another question. Does increase in river salinity affect tornado potential? Again, you have to think about this being a surface thing, and I'm not sure why there would be an increase in river salinity. What would be going into the river to increase that pH or that salinity? But no. Again, what's going on here in the Midwest, and especially here in mostly Pancake Flatville, Illinois, what's going on in rivers, what's going on the surface, that tornado formed, was created hundreds and hundreds of feet above the earth. So the energy that's powering that is happening up there. What's affecting it down at ground level is not going to have a major effect on that tornado. All right, the next one. Why does the Mayfield tornado path look like the tri-state tornado? Well, in a lot of cases, when you look at that overall path, that's generally the way tornadoes form. Now, that's not to say that that's always going to be the case. Back in the 1950s, they put out films to tell everyone to go to the southwest corner of their house to look for it. You could have a tornado coming from the exact opposite side. In general, those thunderstorms, because of the low pressure areas, they're being driven by those upper level winds. Those upper level winds are anywhere from 15 to 25,000 feet above the earth for those thunderstorms, in some cases higher than that. So you're talking essentially miles above the earth. That's the general direction of the jet stream, especially when we're getting thunderstorm development, because when you have that southwest to northeast flow, that can intensify low pressure areas, which in turn can generate increased intensity of thunderstorms. So if the jet stream is going that way, if the thunderstorms that are developed are being pushed along by that upper level wind flow, that's generally the direction that those tornadoes are going to go. Now, those non-supercell tornadoes may not be affected as much by that. And so in those cases, you may get tornadoes, especially in those non-supercell related storms, going in different directions. You know, for example, if it's with a bow echo, where you get those ends rotating, maybe going in an entirely different direction. When does the elevation change affect the occurrence of tornadoes? Good question. There have actually been tornadoes out in the Rockies that have occurred. So, you know, it's not really, tornadoes can happen anywhere. Again, you have to think about these tornadoes. If you've got a mountain that's maybe 10,000 feet tall, yeah, maybe that would affect it. You know, if a tornado is heading directly that way. But otherwise, if it's even just a few thousand feet, may not have a major effect on those tornadoes. Let's see here. Where do you suggest you go in a house with no basement or room without windows during the tornado? Get as far into the center as possible. If you've got some furniture, say a couch or something that you can maybe cover yourself over with in case of flying debris. One question I get sometimes is, what do you do if you're in a car and you can't get away from the tornado? You know, that one is a really tricky one too, because uh, if that tornado is strong enough, it can pick up that car and fling it through, you know, dozens of feet or more. Would it be better to get out and lie in an open, low-lying area? I don't know. I don't think there's been a lot of studies on that either. I think in a lot of cases, they may say to stay in the car, but if you're out in the open, you're not in a car or anything like that, you can't get to any place else. Your best bet in those cases is to lie down in a low-lying area, cover as much of your head and body as possible. Is it usual that a tornado has the sound of a passing train? It's going to have a tremendous sound to it because that air is moving so quickly. So yeah, it's going to have a very big roar to it. And you've probably seen videos over the years where you've seen or heard that loud roar. It's a very ominous sound. I'll be honest, I have never been that close to a tornado to experience it myself. And even though I'm very interested in the subject, I do not need to be right next to a tornado to physically experience it myself. I'll just look at the video. But yeah, it's mainly because of that air moving, that air that's moving at well over 100 miles an hour in some cases. Think about wind. We're getting a lot of wind today. Think about the noise that wind is blowing, and it's only at what, 20 to 30 miles an hour, maybe gusting up to 40. Got a lot of sound with that. Think about winds or air that's blowing at 2 or 3 or 4 times that sound speed. Oops. Okay, as a CUWiSE observer, I found this to be very, oh, well, thank you. Yeah, and I figured we'd have a few CUWiSE observers on there. So I encourage people to do that. That's a great citizen or community science project for people to do. If you're not familiar with what that is, do a search for, if you see that CUWiSE, just put that into a web search and it should bring it right up. It's basically a precipitation monitoring program for volunteers. Some other questions. Have tornadoes that struck the same place more than once ever been studied as to why that happens? It's just the luck of the draw. It's like tornado or like lightning. Lightning can strike more than one place. Tornadoes can do the same thing. You know, some areas, the farmhouse that I grew up in, never directly hit by a tornado, but we've had tornadoes. And actually one of the worst tornado experiences we had was in January when I was a little kid. We had 3 tornadoes hit one evening. One hit about a mile to the west of our farmhouse. One hit about a half a mile to the east. Another one hit about 5 or 6 miles to the southwest of our house and actually hit a house that my aunt lived in. They survived. They got down in the basement, but it twisted the house, basically ruined it. It didn't totally destroy the house, but it did so much damage, they had to tear it down and build a different house. And the really weird thing for that was, again, this was in January. When we went to go examine the house a few days later, we were walking through about 6 inches of snow. Some other questions here. Let me pull the chat up a little bit more so I can get to this. If you're in a brick building and cannot make it down to the stairs fast enough to reach the basement, is it better to take shelter in the stairwell or on the 1st or 2nd floor? I stay on the 1st floor. Again, get to that interior area, interior bathroom or something like that. You want to put as much distance between you and the outside as possible. Which way do tornadoes rotate? There are rare instances where tornadoes may rotate. Instead of in a counterclockwise motion, they may go clockwise. Again, I'm not sure. That's a really good question. I haven't researched that a whole lot. But I think in some cases, they will not or may not rotate always in the same direction. Okay, just a second here. well, this is a direct message, but this may be of interest to everyone. Talking about a microburst, how strong are wind speeds in a microburst? Those downward speeds can get up into the 40, 50, 60 mile an hour category. And once it hits the ground, it spreads out. And one of the things that can happen with the microburst is once it hits the ground and starts spreading out, it will also kind of swirl around itself. And then it concentrates that flow of wind right next to the surface. And so what was originally spreading out maybe at a 40 mile an hour wind, when it spins around on itself and comes back around, it can concentrate that air and create maybe a 60 or 70 mile an hour wind in that area. Can water spouts come on land? Yeah, they can. And then they would just become a land spout. Typically, water spouts, land spouts don't last very long, and they're pretty weak. So in any case, let's move on to the next question. Regarding the increase in recorded light tornadoes since the 50s, is there no doubt in sampling? We can have confidence that all tornadoes, even weak ones, were detected or recorded correct. Can we have evidence that every single tornado has been recorded since the 50s? I'm not sure about that. We've done a much better job of it because we have, again, more spotters out there, more observers. We've got our weather radar out. But speaking of weather radar, one of the things that occurs with those, and these are spread out over several hundred miles, when that radar signal goes out, one of the things that can come into play is as that signal goes out, think about that straight line signal going out, but we live on a curved surface of the earth. So once that signal gets out a couple of hundred miles, we can't actually see what's going on closer to the ground. So there may be a few instances where we've had rotation and we haven't been able to maybe see it as well because that radar signal has gone out so far. We're improving the technology on that. We're getting to the point where now the older radar signals, they had to scan up and down, and they had to scan around. That may take some time. Today, we have radar signals called phased array radar that can look at multiple levels at the same time. And we have the more rapidly rotating radar that can spin around and go up and down more quickly with that. So we're increasing the ability to be able to see those, but we may not have seen them all. And I don't think I'm really answering what you want, but if we want to visit a little bit more, I'd be happy to visit with you a little bit after the webinar today. Oh, here my neck stood up when passing near a tornado. Yeah. Not fear. Well, I don't think I'm going to be able to answer that one either. Maybe the winds were changing. I can't answer that one. I'm sorry. Does hilly country affect tornadoes? Again, it's a matter of what's going on with that tornado. What's happening way above where those hills are at. So typically, no, it doesn't really change the path of it either. In daytime tornadoes, the sky can turn a light mint green before the tornado. That does happen in some cases. Probably what's happening there is there's really heavy precipitation, potential of hail in there. And so it's causing that light to be refracted a little bit. So in those cases where you've got that really heavy precipitation or that potential of hail, that could mean that you've got really strong updraft in there. And if you got that really strong updraft, if there becomes rotation associated with that, that could then be related to a tornado. Doesn't always mean a tornado is going to form in there, but if you see those kind of things, you know, you might be on the lookout for them, or at least be on the lookout for heavy rain and potential for hail. What are dust devils? Dust devils occur particularly in the springtime. They're caused by the rapid afternoon heating of the Earth's surface. You get that air rising up. You got a lot of turbulence at ground level also. So as that air tries to rise up, there may be other air that's moving sideways. So that updraft takes on a rotation. Those things are really cool though. And wind speeds in those things can easily get up to 30, 40 miles an hour in some cases. Where are tornadoes most common? Well, they're still most common out in that tornado alley, which is in eastern Texas, Oklahoma, Kansas, Nebraska, those areas. Oklahoma City is kind of a bullseye for tornadoes, simply because that's kind of an area where supercell storms form pretty easily. These are great questions. Do forests slow tornadoes down a bit? That forest may slow the wind speed down a little bit. It's not going to change the path of the tornado. All right, we've got just a few minutes left. Let me see if I can get through most of these. I was going to mention about lightning. It says hair on neck might have been from maybe a stepped leader that was starting to form. So I thought about that, but I didn't want to mention that you could have been hit by lightning just as much as in that case. How are tornadoes formed? Again, we don't know the final answer on what makes that rotation come to the ground. The research is getting better on that, but they don't have a fits-all answer yet, and I don't think that they will. I think they're going to find that there are multiple mechanisms that make that rotation occur. I don't think that there's going to be one size fits all for these things. Does any other part of the world experience tornadoes besides North America? Yeah, on one of the first slides I showed, tornadoes have occurred on every continent except Antarctica. Are wildlife impacted by tornadoes, or do they have early warning systems that cause them? Well, they may have a sense of something that can occur, and they are usually smart enough to get in out of the rain in a lot of cases, get to shelters. They can still be affected by tornadoes. And there are some, sometimes you hear about birds and other animals that can hear in that infrasonic range. Maybe if they hear the sound of that infrasonic sound that's coming off of a tornado, they may give them some lead time. All right, I think that is it. So again, I thank you. If you have any questions at any time, feel free to email me. My email address is friend, F-R-I-E-N-D, @illinois.edu. And with that, I will close out. And thanks everyone for coming on today.
Thank you for tuning into CUWiseTV. We hope you enjoyed the show. This video can be accessed anytime on YouTube.com. In the YouTube search bar, type in UPTV6 and look for their microphone logo. We hope you will join us again next week for more local and